All right, we're going to be going through the solutions of Worksheet D. Just kind of catching up from large group. We had this free body diagram here with the tension force that is going to be smaller than gravitational force. And the reason for that is that as the block is moving upward, it's on its way of slowing down. And if it's slowing down, there has to be more force down than up with that initial velocity moving upward. Then over to the pulley, you have at this position right here, you have gravity pulling down and you have the normal force pushing right back up. And so those are balanced, but then that leaves the tension force out here that is unbalanced, and that tension force is at a radius away from the pivot point, and that's going to cause torque. So in this space down here in part B, what force is responsible for the net torque on the pulley? The only force that is away from the pivot point is tension, and so tension has to be the amount. I don't know why they give you all this space, but in that space you might indicate that force of gravity and normal don't apply torque because they have zero distance away from the pivot point. All right, so then on the next page they want us to draw the velocity time and acceleration time graphs, and this is just like graph stacking from first semester, so we have to know, okay, is the velocity positive, 0, or positive, 0, or negative to begin with. In order to figure that out, if we just go back over to the first page, they say here that the initial velocity is counterclockwise. And using that, then, counterclockwise results in positive velocities. We know that we need to start off our graph over here with a positive value of velocity. Now it slows down in a very uniform way, and so as we decrease down to 0, we want to have that velocity dropping in a constant way because of the steady net torque. And then this is, at this moment, when it hits 0 velocity. That's that brief instantaneous stop, and then it's going to continue on straight through the axis to make just a diagonal line. And what that's showing down on the other side is that as this thing gets larger and larger in velocity values in the negative direction, this thing is speeding up back the other direction. So we slow down, slow down, slow down, slow down to a stop, and then speed up, speed up, speed up as it unravels back the other direction. Over on the acceleration time graph, that's going to result in just a uniform negative acceleration that does not change over the whole time period. All right, and that's it for Worksheet D. Go on to the next video if you want to see the solutions to Worksheet E.